Okay, welcome back to my channel to Cube Learning. So in this session we are talking about the how determine the minimum required height of the pump. So as you can see, so I draw the sketch that the pump that we are going to size in here. So in this session we are going to size this pump with the upstream, this distillation column of the bottom product, and we want to transfer for the bottom product to the storage tank. Okay, so in this session I just want to share that if you want to size the pump, we have to define first the section is discharge of the pump section as the segment 2, and then there are also the suction of pump in here. So this is the suction pump, and here is the discharge pump. So we have to calculate first where is the pressure drop across this segment, the suction pump, and the pressure drop across the discharge pump. So first of all, I just want to show you that when we are calculate of the pressure drop, so I think we have to see that we have the API RP14A, and as you can see here is the fanning equation factor. So maybe you can use this equation when you calculate the pressure drop across the pipeline. So as you can see, if this delta P per line of pipe, and then is the okay. And in this session, so we have to adjust this pipe diameter in here. So maybe if you want to decrease the pressure drop across the pipe, you have to increase also your pipe diameter. And if you want to decrease, and if you want to increase your pressure drop, maybe you just decrease also for the size of your pipe. So it's depend on what can I say, it's depend on your project specification. So I have specified the given data in this session. So the given data can be referred as project spec. First is product capacity of this pump. So we need to determine first which how many the capacity that you want to into your pump. And the second one is the tank residence time itself. So we need to specify in project specification how much the minimum residence time that will be happen in this tank. And then the third one is the pressure drop. Okay, this pressure drop, maybe you can choose the maximum dp per L is no more than 0.4 kg is for example. And then for the max velocity, you can say that no more than 2 meters per second. It's just based on your project specification. Okay, for the setting of this pump, we have to calculate so the DWSIM as usual. So I will go to the DWSIM as well. Okay, so I'm using the DWSIM because it's free simulation and it's very easy to simulate and calculate the differential height of the pump. Okay, first you can create new in here. Okay, So is the new worksheet that I've made to size my palm. Then you can next. So I will simulate with the propane and the propylene. So we need to propane and then propylene. So this is just for example. So maybe if you want to simulate the more heavier crude oil, you can also fill it with different one. Propane and propylene is just for the example. Okay, next, and then I will choose the Peng-Robinson property package because it will match with my compound that I studied in the earlier session. The Peng-Robinson I will add and click next, and then for the system of measurement I choose the for C1 because the C1 is very familiar with the industrial standard. So maybe you can use for the C1 if you are the expert in industry. Okay, finish. Okay, the first we have to put some material stream in here. Okay, the material stream. So we need to specify it for the suction of the pump first because we need to obtain two different parameters: the suction of the pump and minimum discharge required of the pump. And then you can go to the pressure changers and choose the pipe segment here. Okay. Okay, maybe I will disable for the auto connect because I will add it manually to make it easier. Okay, and then I will define first for the pressure and temperature because we need to ensure that the vapor phase is become zero, because the pump is done with the single phase. There is liquid phase, not vapor phase, so I have to increase the temperature here with maybe just okay, maybe 12 kg. Okay, that's it. Okay, and then the temperature is okay, no problem. Is for the 25. Okay, no problem. Maybe just 30. To increase to ensure that it's the liquid phase. Maybe it's just 30. Okay. So we have to define first for the hydraulic profile in here. Strike 2. Okay. Then we have to calculate in here to specify the materials for the pipe with the carbon steel, and then for the length and just input for the 40 meter, and the elevation because this is the suction pump, maybe for the bottom from the fractionator, the suction inlet of the pump, it will be decreased elevation. So I will input with the negative value in here, negative 0.3. Okay, so maybe I just to ensure that for the section pipe size is around 6. Okay, 6 inch in here. Okay, 6 in here. Okay, maybe if you can add also in here with some structure also, maybe you can also put some the elbow or just this very lot of the fitting that you want to choose, and then you can choose this one and then you can input it to your calculation. It's up to you guys. So for this next strike, I will carbon steel also. The length is 30, and the deviation is 0 because the pipe is just horizontal strike line. And then the external diameter I will put the same as the previous one, 6" in here. Okay, and we have to calculate it. Okay, so as you can see, we have the pressure difference is negative because I have put here is this the negative zero, and I want just to ensure that the pressure is not negative. So maybe you can also here put the sum 0.1. Then you can calculate. Okay, so maybe to make sure that the pressure is not negative in here, and just to ensure that we have to put the cooler, because this is the outlet of the fractionator, so we need to cool it first with the cooling water maybe. So I have to put one equipment here with some cooler. Okay, maybe it's just the column or exchanger, cooler. Okay, so for the cooler, the inlet stream is the 5 stream. You can auto-generate, and other stream you can auto-generate also. Okay, so for this cooler, the calculation type is this, because this to make easy. So I will change it to outlet temperature, and then you can change because this is cooler, maybe you can put it with some 32. Okay, 30 to 30. So okay, I will change it to make it reliable, maybe 2.6 here. Okay, the efficiency, we can assume the 100 efficiency for the pressure drop. The commons of the pressure drop of the cooler is around 0.5 or 0.6. There's no problem. Okay, so in here we're gonna see for the vapor phase. Okay, this is a 0 vapor phase. Then we have done for the section for the suction segment of the pump. So we need to calculate also for the discharge section of the pump. So as we have shown in the error, we have to state it for the stream and then pipe segment. Okay, you can see here this one. I will connect it to the stream number 9. I will auto generate for the other stream. Okay, we have to specify for the discharge pipe segment in here with the hydraulic profile. We have to input it for the carbon steel, and then okay, for so let's attention for this one, because basically the pipe size for the discharge pump is bigger rather than the suction of the pump. The pipe discharge of the pump is less or is lower than smaller than the suction of the pump. So I have to specify for the size, the pipe size for the discharge pump is about 4. We have to specify 4 in here. Okay, for the length maybe is the 1 kilometer in here. Because as you can see, we can assume that is That's the distance for the pump to the final storage is very far away, so we can specify for the length as the 1 kilometer, and the elevation maybe we can specify as the 1 meter here, and the external diameter we can specify as 4, because in the suction of the pump we specify for the size of the pipe is 6, so we have decreased it to the 4. Okay, it's 4 STD. Okay, can calculate it and solve. Okay, this error because sorry, I have to rectify first for this one. 26. Okay, this is the negative pressure. Sorry, where's the negative pressure? Okay, is the 4 kg, and here is okay, this one. So I have to increase first because as you can see, this the identified calculation. The pipe is negative, so we have to increase it. Maybe just 70 here. Okay. Okay, that's all. That's done. Okay, why we have to increase? Because the pressure drop is quite high, so we need to increase for the pressure in the upstream. This is just a preliminary assumption, because we need to align with the downstream pressure for the target is the destination pressure. Okay, sometimes we need to pressure regulating in here, so we have to add the control valve and the outlet of the stream number 11. So in here, okay, get the control valve in here. Inlet stream for the number 11. Okay. Then we have to specify for the final storage of the tank. Stream number 14 and auto generate for the outlet. Okay. So let we see if because this is the propane and the propylene, we have to specify in here as the one single phase. So we have to ensure the stream number 14 is just one single phase in liquid phase. Okay, so that's all. Okay, that's okay. So the vapor phase is 0 in here, and then we have to define for this one for the pressure drop. Maybe because this the control valve, the 4-inch control valve is practically because maybe it's around 1.5 kg. 1.5 kg, so we need to check it. Okay, the pressure is around 15, and this okay. So the target, so we need to okay. So for the tank value, we have to finalize after we combine it to the pump in here. So the destination pressure, as I stated earlier, so we have to ensure that the stream number 14 is about the pressure is maybe 18 or just 20, so we have to increase for this one. Okay, so we have to put the pump in here because we are finished to calculate the suction and the discharge. So we have to add the pump in here, and then let's connect it to the stream number 7, and for the outlet to the stream number 9. Okay, auto generate for the stream. Okay, so it's automatically calculated that all simulation has converted. Okay, so you can see in here, okay, is the 12, and then it's the 12. Okay, it's the same. Okay, so we need to increase the pressure because our target pressure, the destination pressure for the tank, for this tank is 20. So we need to increase the pressure increase in here. Maybe so we have to outlet pressure in here. So maybe it's just 23, and then we can check it in here. Okay, so we have to decrease 4 point. Okay, done. This is the 20. Okay, the 20.40. Okay, blah blah blah. Okay, it's no problem because this let's say this is just the margin of the target pressure. So we have to define our pump. So we have pump in here as the differential head with the 9.4 in here. Okay, so please ensure that the flow capacity is based on your project specification. So maybe you can adjust the mesh flow and to ensure this mesh flow in line with your project specification or your project design, because this relate to the capacity. Maybe if you want to, the capacity of this system is around 8,000 kg per hour. Okay, 8,000 kg per hour. So as I mentioned in the earlier, because we have to define our tank value, this is just preliminary. Maybe I just this 6. Okay, so the resident time is about 3,000 is around 1 hour. So is as you can see in here, so we need to inline the fluid residence time with your project specification. Maybe if you want to increase your residence time, maybe you have to increase the tank value. Just to transform to 20. Yeah, the fluid residence time is also increased, because in industrial is just the owner specification how much the fluid residence time that will be apply for the system. It is just maybe 2 hours, or okay, maybe 2 hours is okay. 2 hours is about the 7,200. Yeah, 7,200. So maybe I have to increase it to maybe 35 or 30, 32. Okay, 33. Okay, so the fluid residence time is become 2 hours and is comply with your project specification. And then we have the tank volume, because I guess the tank volume is the net working volume in here, so we need to add the net total working volume as the standard, or just you can refer also for this tank with the API. Okay, so the last I have to extract for this pump datasheet, because the DWSIM can automatically extract the report of this pump. Okay, before I do it, maybe I need to check the capacity. The capacity of our system is about 8,000 kg per hour, and the resident time of the tank is about 2 hours in here, with 33 cubic meter net working volume of the tank. Okay, so we need to know how much the NPSH availability for this pump, because NPSH is very important to know before we are going to purchase of the pump. So we need to compare it with the manufacturing minimum required of NPSH. So you can go to the result, create report, pump, and view report. Okay, as you can see in here, so we have the head of the pump around 9.4 kg. The efficiency is this, because the efficiency is just preliminary, so you can specify as you want in here. And then temperature difference, we have the 1.1 and power required. Okay, this is very important for the power required, so we have to because we need to vendor advices for the power required that we have to purchase of the pump. And then is the most important that we need to, if we have to purchase of the pump. So in this session we have the available NPSH around 24 meters. Okay, I think it is very high NPSH, so I think it's no problem if you can buy the pump with low NPSH requirement, so your pump really gonna work as well. And then the outlet pressure is around 22 kg. So you can print for your simulation report in here in the worksheet, or just in the PDF as you want. Okay, so maybe in this session maybe you can also you can update it for the pipe size in here as you want, because I check that my pipe size in here is just 6, and the suction in the at the section and at the discharge pipe size is around is 4, yeah, is 4 inch, and the suction is 6 inch, because the suction pipe is practically much bigger rather than the discharge pipe, because it's just the hydraulic effect. Because as you can see, the flow capacity will decrease if you increase your pipe size, and then it will be avoid or prevent your pump with the cavitation, because you need to ensure that the flow capacity in your suction of the pump is not high as the flow in the discharge your pump. Okay, I think that's all about my video in this session. Don't forget to share and comment if my video is very useful for you, and then you can also follow my LinkedIn in David Wahyu Permadi, and then you can post your comment in my LinkedIn on we have to connect it, and then we can go discussion regarding the pump sizing. Okay, thank you, bye bye.